The control of hazardous energy sources, commonly known as lockout tagout, covers the use and maintenance of machines and equipment in which the unexpected energization or startup of the machines or equipment or release of stored energy could cause injury to employees. Lockout requires that energy sources for equipment be turned off or disconnected and that the switch or energy source be locked. Tagout requires that the equipment or switch be turned off or disconnected and labeled with a warning tag. In the event a lockout device cannot be applied, the energy source must be isolated by other mechanical means such as blocking, caging, removal of a switch or handle, and so forth. OSHA's standard for the control of hazardous energy, lockout tagout, requires employers to develop an energy control program. This program must contain the adoption and utilization of written procedures for shutting off and disabling machines and equipment whenever maintenance or servicing is performed on those machines and equipment. The program must also provide for the instruction for using the procedures and the periodic inspection of equipment being locked out or tagged out to ensure that employees are properly using the prescribed procedures. The regulations establish two categories of employees. Affected employees are those who operate or work around equipment that may be locked out or tagged out. Authorized employees are those who lock out or tag out equipment in order to perform service or maintenance. They must be trained in the procedures and must be provided with locks and tags. These locks are to be durable, standardized, and must be marked to indicate the employee to whom issued. Each lock must use a different key to prevent removal by someone other than the employee who applied it. Tags must be weather resistant and contain a warning such as "Do not operate" or "Out of service." When more than one individual is involved in working on the source equipment, each is required to apply a lockout tagout device. In this case, a group lockout device, such as a multiple lock hasp, must be used. All employees are prohibited from restarting or re-energizing equipment that is locked out or tagged out. Any employee who violates any provision of the lockout tagout program is subject to discipline up to and including termination. Each lockout tagout device may only be removed by the employee who applied the device. In the event that employee is not in the facility, the device may only be removed by a manager or supervisor after he or she ensures that it is safe to remove the device. When a lockout tagout device must be temporarily removed to perform testing of the equipment, the authorized employee must clear the equipment of all tools and material and ensure that all personnel are safely positioned before removing the devices and starting the equipment. When servicing or performing maintenance on a piece of equipment continues through a shift or personnel change, the off-going authorized employees and oncoming employees must transfer their lockout tagout devices in a manner which controls the isolation of the energy sources. Procedures have been developed for various types of vehicles and equipment. By category, they are A, trucks, B, heavy equipment, C, trailers, D, compactors and balers, E, conveyors, F, electrical powered machinery and support equipment, G, engine driven machinery and support equipment, H, submersible pumps and control panels. Employees and their supervisors must review these procedures before employees are allowed to work on such equipment. Similar procedures must be prepared and reviewed for other special equipment such as that found in material recovery facilities, gas recovery, electric generating plants, leachate pre-treatment plants, and others. The first step in all lockout tagout procedures is to identify the potential energy sources that will require control by lockout or tagout. In general, there are 6 types of energy sources that may be encountered. 1. Electrical energy. A. It may be a high-voltage electrical system ranging from 110 to 480 volts operating machinery. Hazards present would be possible electrocution, shock, burns, or startup of the unit. B. The electrical energy source may be a 12 to 24 volt automotive battery charging system that controls the operation of an engine. The hazard present would be from startup and operation of unit or sparks from shorts in the system. 2. Mechanical energy. A. First of all, there is the danger of moving parts when an engine or unit is operating. Examples of this are rotating fans, shafts, gears, grinding wheels, moving packer blades, panels, conveyors, and more. B. There is also potential energy in items that could move or fall due to gravity. Examples of this would be an elevated truck body, tilted truck cab, raised tailgates, doors, loader buckets, dozer blades, and forklift booms. Conveyor belts also have the potential of moving because they can run backwards if the drive mechanism is released. C. Other stored potential energy can be present due to compressed springs, as in parking brake chambers, back pressure caused by compressed refuse in a packer body or compactor or baler chamber, or tension in a jammed conveyor belt. 3. Hydraulic energy. Hydraulic systems work using fluid under pressure. The energy can be present due to the operating system pressure. There can also be residual stored energy in the system due to an external force being applied. Pressure may also be present in cooling, lubrication, and fuel systems. 4. Pneumatic energy. An example of pneumatic energy is air pressure stored in an air brake system. Pressure may also be present in air accessories and control systems. 5. Thermal energy. Thermal energy is heat from fluids such as coolant and lubricating oils, and from hot machinery such as engines, exhaust systems, electric motors, and gear cases are sources of potential thermal energy. 6. Chemical energy. Potential energy can be released by chemicals when they react with one another, react with air and or water, or which react with your skin, eyes, nose, or throat. Possible chemical exposure includes exposure to fuels, coolants, oils present in machinery, leachate in landfill collection systems, or any liquid cargo carried in a bulk tanker. Now that we have identified potential energy sources, we have to determine which switch, valve, or other isolating device will be operated to isolate these energy sources. Whenever working on equipment in a manner in which any potential energy source could be encountered, appropriate procedures must be followed to isolate or disable the applicable hazard. The following are various means to isolate these energy sources. 1. Electrical energy. A. For high-voltage electrical equipment, shut off the unit at the control panel with the switch or key, or by depressing an emergency stop button. Locate the master electrical disconnect switch for the particular machine and move the control lever to the off position. According to the American National Standards Institute Z-245.2 for stationary compactors, a lockable disconnect switch is to be within sight of the machine and not more than 50 feet away. While the regulations do not specifically apply to electrical equipment, which can be disconnected by the unplugging of the electrical cord from the power source, lockout devices are available to ensure that the equipment cannot be replugged in. B. For an automotive electrical system, shut off the ignition key or switch and shut off the battery disconnect switch, which is generally located near the batteries. 2. Mechanical energy. A. Shut off the operation of the engine or machine. B. Set the parking brakes of the vehicles. Shock the wheels if the brakes are to be released or the unit is to be raised off the ground. To ensure that unhooked semi-trailers are not moved, a locking device can be placed on the kingpin. C. Lower any raised body and all components to the ground or the at-rest position. Securely block any raised component by using a jack stand, a fixed prop, or a restraining device such as a sleeve over a hydraulic cylinder rod. Some conveyor belt drive motors are equipped with an automatic brake. In the event that they are not, a mechanical means of blocking, such as placing an external backstop on the conveyor or lock bar on the drive gear, will have to be used. D. Release any stored pressure from compressed refuse by moving the ejector, blade, or panel in the reverse direction. If unable to release the pressure, securely block the blade or panel in place. E. Ensure any compressed springs are secured, for example, cage parking brake spring per manufacturer's instructions. 3. Hydraulic energy. A. Shut off the unit or machine. This stops the hydraulic pump and relieves the operating pressure throughout the system. B. Bleed off any internal pressure by lowering all components to the at-rest position and moving all control levers in each direction and leave in neutral position. C. Relieve pressure in the cooling systems by slowly releasing the filler cap. 4. Pneumatic pressure. Bleed down the air pressure by draining the petcock valve on all reservoirs. 5. Thermal energy. Allow sufficient time to cool before beginning work. 6. Chemical energy. A. Ensure that all pipes, lines, valves, and similar sources are secure to prevent the inadvertent release of any chemicals or liquid cargo and to prevent incompatible chemicals from mixing. On tankers, in addition to having the valves tightly closed, ensure that the outlet pipes have covers on and are secured. B. In servicing coolant, fuel, lubricants, and hydraulic oil systems, perform the work in the proper manner to avoid spilling of these fluids. In addition to isolating the potential energy source as mentioned above, lockout tagout devices will be used as follows. 1. Lockout by service personnel performing maintenance and repairs. Shut off the unit with the control switch or the vehicle with the ignition switch. On equipment, turn the master electrical disconnect lever to off and padlock. On vehicles, turn off the battery disconnect switch and padlock. Place an out-of-service or do not operate tag at the point of lockout or on switches on the control panel for machinery or on the steering wheel of vehicles. Do not operate steering wheel covers may also be used. 2. Lockout of vehicles by drivers in field operations, for example, for cleaning of bodies or exchanging compactor containers at customer site. Shut off the unit and remove the key from the ignition or control switch. On vehicles, also turn the battery disconnect switch to the off position. After the lockout has been applied and before work on a unit is started, an authorized person must test to ensure that the potential energy sources have been isolated as follows. A. Electrical. The authorized employee will attempt to restart the equipment by actuating the start switch. Note, if repairs are to be made inside an electrical panel, a voltmeter is to be used to check that applicable circuits are dead. Any lights or electrical accessories should also be tried. B. Mechanical. An authorized employee will check that all components are lowered to ground level or the at-rest position and or are safely blocked as necessary. Remember, this may be accomplished in one of three ways: using jack stands, fixed props, or a restraining sleeve over a hydraulic cylinder rod. C. Hydraulic. An authorized employee will move hydraulic system controls to check that they are in the neutral position and that no power is present. D. Pneumatic. An authorized employee will check that air pressure is released. E. Thermal. An authorized employee will determine if equipment has sufficiently cooled. F. Chemical. An authorized employee will check that all valves, lines, and piping are properly secured. Outside contractors working on equipment at our facilities must be informed of hazards and have the opportunity to receive a copy of the lockout tagout procedures for the piece of equipment that they are requested to service. The facility manager must be informed of the outside contractor's lockout tagout procedures. OSHA requires that the lockout tagout program be reviewed once a year and that periodic inspections of the procedures are made to ensure that they are being followed correctly. Following these procedures will ensure your safety and that of others. Remember, don't take chances. Make sure you control all potentially hazardous energy sources before you service any vehicle, equipment, or machine. Thank you.